All right, so let's get started with today's class. I guess the first thing I want to mention is I finished grading the midterms. We're going to be talking more about them on Wednesday. So we're really gonna, explore more the questions, what maybe was confusing, and clarify some points, and perhaps have a special assignment after that for the midterm. So, putting the midterm aside, today our goal is to finalize the soil ECA exercise. So this, just close that. So this is the project that we started a couple classes ago that was called the 06 Soil EC project. So please go ahead and launch your RProj to have this appearing on your screen. This is what it should look like. And again, make sure you are on the right project and that you have your partial script popped up. We stopped at this chunk here. So what we did last time that we met was basically import the soil EC data. We did some wrangling, some EDA on 2 depths of the EC. We brought in the boundary, created the grid, did the interpolation for the shallow layer, so the 0 to 30 centimeter layer. And then we stopped at creating a map for that interpolated map, right? So if you come on this chunk here, you just want to run all above. So we have on your environment the variables that we need to continue today. Right, so this is the chunk that we're going to start developing now. Come on in, guys. I was just telling everyone we're just continuing our EC exercise that we started a couple of classes ago. So if you just want to launch that and then run all above to get all of your objects ready to go, we stopped last time that we worked on this. We stopped on the chunk that we were going to create a map of the shallow EC already interpolated. Right, so I guess this is a good reminder, if you missed this question on the midterm, our interpolation method is IDW, that's the acronym. It stands for inverse distance weighted. That was one of the questions. And the 2 functions that we use to do that is gstat and predict. That's how we do this type of interpolation. So we did that today already, or we had already done in the past for the shallow 0 to 30 centimeter layer. And now today we're going to start with our goal of just creating that interpolated map so we can visualize our results. So if you're on this chunk here, we're going to basically develop a ggplot from this point on, where we're going to save that ggplot that we create to this object called ECA_30_map. So as you know, so go ahead and give it the assignment symbol. And as you know, we started ggplot calling ggplot first. So go ahead and do that. So one thing I want to do more is just ask, especially now at this stage of the class where we've been doing some of these things a lot, right? And I do want to ask more of your thoughts of how can we do things. So you can help me and we all work together on this. So let's start first here with someone in Athens. So that we just created this object here using the predict function that is the interpolated shallow ECA data, right? If we print it, so this is the object that we're going to be using to plot next. If we print it, what type of object is this? Stars, right? Does that mean it is vector or raster? Raster, right? So because it is a raster object, I'm just going to copy its name because we're going to use next. What is the geom that we should use to plot it? Stars, yes. Okay, so let's go ahead and give it a geom stars. We need to say data equals, and then I'm just gonna paste the name of that object. If you didn't copy, you can just start typing and use autocompletion after that. If I just run this and print this object that we're saving into, this is how it looks like. So if you're probably thinking this is not the last version. We need to do a few things to make this look nice, right? It's not looking nice yet. So what would be, I mean, there may be a few things that we can change here, and the order of them, I guess, is not super important, but what is one thing that you would change about this plot? Next. Bo, what you think? What you think we can change about this plot next?
Probably the color scale, maybe.
Yes, I agree with that. So even though you on your side, when you're doing your assignments and coding, you can choose whatever color you want. I do want to specify one here that is the Virides, right? So it's a colorblind scale. So to change that, we say scale underscore. In this case, so let me show you something here that perhaps wasn't as clear, and I just want to make that very clear. So with geom stars in geom-SF, if your object that is coming in only has one column, well, I guess here we do have two columns, but it is using the first one in this case to plot, right? So we're not saying here like color equals y1pred or fill equals y1pred. We're not saying that here, but that only happens with geom stars and geom-SF. For every other geom, you have to say within the AES, you have to say color equals fill equals some variable. So especially for geom stars in SF, that behavior is a little bit different because already assuming the first color is what you want to color with. So just by looking at this code, we don't really know if it is coloring y1pred using the color argument or the fill argument, right? So meaning that if it is using the color, then we would say scale underscore color underscore Virides B or C actually, so for continuous. So this is what I want to do. If assuming that geom stars is changing color based on y1pred, let's run that and see what happens. So the code runs, right? It doesn't give us any errors or warnings. However, the color of the map was not changed. And the reason for that is because, in fact, geom stars is changing the fill argument, not the color argument. So how do we then change this to match the scale that we want? Is to basically replace color here with fill. So if we run that now and we print it, now we did what we wanted. And again, on geom stars and geom-SF, this is a little bit obscure because it's not explicitly appearing on the code fill equals color equals. It's already doing by itself behind the scenes. However, with every other geom that we use, we do specify that, right? So, I mean, it doesn't make sense what I'm going to show you now for this plot, but let's say if it was not a map, if we were doing like a geom point, right? And I wanted to color the points according to y1pred, I would have to do that inside AES and explicitly say color equals y1pred. I'm not going to run it because, again, it doesn't make sense for this case. We're not plotting points, but I just wanted to make that distinction. Because this, the scale underscore points, like dotted points, was one question on the exam. And I noticed that some of you, like the way that you would have guessed what you should fill here or what you should write on this blank space is based on what the AES above was telling you. So if the AES above was changing color, this should have been color. If the AES above was changing fill, this should have been fill. So that's how you know this. And I guess I wasn't super explicit about it as I'm being now before the exam. Okay, so I do like that change. What else can we change here? Different, let me look online. See if somebody online can help me. So let me ask Kriti. Kriti, what do you think we can change next on the spot here to make it look more professional?
Theme map.
Say that again?
Theme map.
Theme map. Okay, I like it. Let's do it. So that is one of the things that I have also in my code. So go ahead and add a plus. I do want to propose that I mean, we could use theme_map as Pretty is proposing, and that would be completely fine. It will look like this. I do, however, want to propose that we use the theme that we created in the beginning of this script, which was called my theme_map, right? So, but your answer is great, Pretty. Thank you. So it was called my theme_map. It's just because it's a theme that we further, customize a little bit more to make it look like a specific way. Okay, what else can we change in this plot here to make it look more professional, right? So if you think that, like, if you were to publish this in a paper, it's still not ready for that. What else would you change? Maybe let me ask, let's see, can I ask? Umar, what do you think?
So I think we need to change the name of legend, the title of legend, and X and Y axis name as well.
Awesome, I agree with that. So the Y and X axis are already removed because this is a plot, and at least the theme that we chose removed those, so we don't really have to change them because they're not even there. But I do agree that we have to change the way that our legend appears, right? So I'm gonna jump in and give you part of that. So the way that we change that is by using the labs function, right? And because we are changing, as we already discovered, we're changing the fill. So we have to say here inside of the labs function, we can say fill equals open and close quotation marks, and then give it a new name, right? So if we were changing the color instead, then this should have been colored on the labs as well. So what I want to call this is, so ECA, give the depth, so 0.30 centimeters, and give it the units, right? So within parentheses. So this is in deci-Siemens per meter. This is how you would say that. If you go ahead and run this and print it, it changed as we expected. However, it also did something that I would further customize, which is we have a kind of a long name for a short, like on the horizontal direction, we have a long name for a short scale, right? So what I would do here is basically break line. So break line after ECA and break line again after centimeters to have this long one line name to be in three lines. So the way that we do that when we're talking about text in R is by using this /n symbol. So this is the symbol here, /n. And if you really don't even have space in between what comes before and after it, it still works. So if we just do that and we print it, it broke line at ECA. We can do the same thing after centimeters. So if it's easier for you to visualize, you can give it a space so you can see what you're doing. But then before you give that space to visualize, you can just remove that space so it can be more compact. Awesome. Okay, so on my side, there is one more thing that I have on my code that I want to do here. One last thing that I want to change before we move to the next one. Can anyone suggest something? Perhaps someone can guess what at least I was thinking.
We need to import or include the boundary so that it will have the projected map.
Perfect. That's exactly it. Thanks, Sekar. So we just add a plus here. To do that, we're going to use. So, well, let me ask someone else now. So the boundary, just to refresh our memories, we imported that up here, right? So it is called, the object is called boundary W. And if we print it, it is a simple feature type of object. Given that, what function do we need then to plot it here? GeoMSF, yes. So let's go ahead and do GeoMSF. we need to say data equals, and then the object name, so that is boundary underscore W. And if we run as is, this happens, right? So we have, this has happened a lot of times already, and we have already fixed this a lot of times, but I want to ask, let's see, maybe Doster, how can we fix this?
I guess I'm trying to understand why it did that first.
Yeah, so, well, so maybe let me change my question then. What is wrong here? Like,
It's not displaying the data within the boundary. It kind of looks like it's trying to display the data outside of the boundary. But there's no data outside the boundary.
so that is close. So what happens here is when we bring in the boundary is solid, like we cannot see through it, right?
So you have to increase the transparency.
Yes, so you're going the right way. Okay, so we have to basically, so we want to keep the outline, but we don't want the fill, right? So the fill of the boundary, we want that to be completely transparent so we can see through it and see the data behind it. How do you think we can do that here in code?
So we did it before, but I'm trying to remember. There's a certain.
Okay, if we just,
Sorry, somebody online said something?
yeah, is it okay if we jump in also?
Yes, absolutely. Is that okay, Doster?
Oh, yeah, yeah.
Okay, yeah. Yes, go ahead.
Okay, you have the comma after boundary underscore W. What I did was still equals NA, and it set the transparency.
Yes, and that is Miller, is that right?
No, it was Ethan.
Ethan, awesome. Thanks, Ethan. Appreciate it. That's exactly it. Yeah, so if we come here, so Doster, you were going the right direction. And I just, yes, I'm gonna have a question.
Yes, like what will be the difference if we fill NA or alpha is equals to 0?
You know, that's a good question. And I guess I don't know the answer. The way I would explore that is by basically trying out both, right? So what I was
Both
going,
give the same results.
the same result. So let me try. So yeah, that's a great point. Yeah, that is actually spot on. It's really, it's the same. So what I had shown you before was to do fill equals NA. Right, so this would be what I was going to propose. But I guess, you know, Doster was going that direction of talking about transparency, because fill, there is no in between. It's either you have it or you don't have it, right? Is it either complete there or not there? But with transparency, you can adjust it, right? It goes from 0 to 1. So let's say fill, it's either there or not. But if we were changing transparency, perhaps we can play around with that. Because so transparency we change with alpha. And if we say alpha equals 0, that's fully transparent. If we say alpha equals 1, it's fully solid. And then you can play with values in between, right? So let's say if I do alpha equals 0.3, you still see some of it, right? Which at least the way that I'm thinking about it, I really don't want to see any fill, right? So in that case, I guess I would either do alpha equals 0 or fill equals NA. Both of those would work. Yes, both.
And so, as you were doing all that, I was just kind of thinking in my head why it was, you would be covering everything. And so I thought of like, you know, when you insert a picture into a Word document, sometimes it'll wrap above the text.
Mhm.
So that's what I was thinking. So what I basically did was I just took GeoMSF and I did the very first part and I took the fill out. And it looks exactly the same.
Perfect.
Start with the GeoMSF.
That's awesome. Let me just repeat that so people online can hear in case you didn't hear the whole thing. So Bo was just saying like, I mean, I guess summarizing what Bo was saying is, what if we basically just change the order of how we are presenting things in the plot in a way that we bring first the boundary and then the stars object. So the stars is on top of the boundary instead of the opposite. So that's exactly another way of doing this. And I'm super happy that you guys are thinking like outside of what I'm telling you. Because so if we were, I'm going to do that here just so you see, right? So if the first thing that I bring in is the boundary with the geom SF. And then I bring the stars. That's exactly what happens, right? So the boundary is behind it, and the stars now, so the IDW results are on top.
You don't even have to have that extra code, the alpha part.
Let's try that. Yeah, so that's the same result. However, one thing to notice is so we could have done this in this concept of like what you bring, the sequence you give things can impact your output. In this case, which geom you bring in first impacts that. That applies to every ggplot. So every time you're bringing multiple geoms, whatever you bring first is going to come first. And if you bring something else that is on top of it, it's going to cover it, right? And so you can just play with the order. However, here, I'm just looking closely. I don't think I can see the actual boundary, right? Even though it reshaped the map the way we wanted, but I don't really see the boundary. So perhaps, I mean, if I come here, maybe change the size of the boundary outline, maybe that would help. Let's see. No, it didn't. So even though the boundary did change the way the map looks, which is one of the things we wanted to do with it, but I still don't see the outline. So I think if our goal is to do both of those things of changing the way the map looks, but also changing the outline, I would bring the boundary after the IDW, and it would do either alpha equals 0 or fill equals NA. Because then I can still see the outline, but see the points through it as well. Right, so if we do that now, if you look closely, you can see the boundary because we're bringing the boundary after. So the boundary is not hidden by the data, but that was a great observation, Bo. Thanks. All right, so as far as I had planned, this is pretty much the map I wanted to produce at this point. So it looks nice. It would be, almost ready for publication, but I guess as far as we're concerned, this is pretty good quality already. Any thoughts on this? Yes, Dennis.
Yeah, when I look at it, I see as if it is bland, not that much clear. I don't know. But the other thing I was trying to ask myself, we have to use this area and come up with some conclusions, like which areas, which ones, but I feel like maybe the ones in number 8, maybe the ones with the highest conductivity. And probably not suitable for field, maybe they need some indication or whatever. I was trying to go through such kind of ideas.
Yeah. So Dennis is asking here. So I guess like stepping outside of like map making and aesthetics, Dennis was asking about more the interpretation behind it. So he was looking at this map, looking at the colors, looking at the scale of the colors, and he made the point that perhaps the areas where we have the yellow areas where we have higher EC would be not as ideal for agriculture. Is that what you were saying? Yeah. Compared to the blue areas that have lower EC. So let me ask you this: why do you think that is?
I was thinking that because if you go like some factors which affect the higher productivity, like maybe there is more saline or there is I was like going for such kind of areas, though there might be other factors, maybe maybe there was high moisture content, things like that. So I was thinking, what is behind on this map at this time?
Okay.
Yeah.
So before I tell you anything further, let me ask someone online. So I don't know if you online could hear, but so Dennis was saying that he thinks that here higher EC could be bad because it could have been wetter areas that had higher moisture and therefore a higher EC, and could also be areas that you have a lot of salt, so like saline conditions that are not good for crop development. Let me ask maybe Anish, what do you think about that? Well, I guess let me ask you this: can you think of the opposite situation? Like, can you think about a situation where higher is good and lower is bad?
Maybe we think about the texture.
Higher ECA is good in case of higher soil organic content, higher bulk
The higher ECA might be because of the higher organic matter content in the soil.
Okay. So then so what you're saying,
So might be good for the plants.
also clay soil, which is good for some of the plants.
okay, so organic matter, what about texture? How would texture play a role here? Like, where?
So it should be more clay,
Mhm. More clay,
and then. So I think more clay will not be that good to the plants, because more clay, that they won't allow water to be absorbed easily by the plants.
okay, so where
So-
in this plot, what do you think you would have more clay given the data that we're seeing?
So in the allo region,
Okay,
where the ECA is high.
okay, awesome, thank you. Okay, so this actually brings up a great conversation, which is, at this point, we don't know. We don't know if high EC or low EC is good or bad. And that is because of one of the things we talked about in the EC class is that EC data is very site specific, right? If I go to the neighboring site of this one and I do the same values the same day, I may get for the shallow a different range. It could range from like 10 to 20. Is this not comparable, right? So it's very, very site specific. And until you have other types of data to use with it, you don't really know if high or low is good or bad. Now, let me ask someone else, maybe Trip. Which layer do you think we could use with this to understand if high or low EC is good or bad?
Yield map.
Yes, yield map, right? And we have that, and we're actually going to do that after we finish this exercise here, is we're going to validate some of our findings by combining these layers. So if we bring in yield data here and we know that yield data has been interpolated using the same grid, the same cell size, so we should line up perfectly with this. So we can really do a one-to-one comparison and do a scatter plot where in one axis you have EC, the other one you have yield, and see how the relationship goes for this field specifically, right? So again, it's very field specific, and you have to have some type of way to check if for this field, high or low EC is good or bad. And yield is the perfect layer to do that. So we're actually going to do that. Yeah.
Yeah, I was trying to think about it like the soil texture
Mm-hmm.
and like going to play like someone proposed.
Mm-hmm.
So, but if like practically looking on the size of the farm, and we have those small clay or texture, small fine texture like that in the field, and say that yellow is because of that, I will assume like maybe most of the soil is the same, and maybe those yellow stuff are not about the clay issues or texture, they are about the other factors, possibly salinity.
So if you do, so I don't know if you online could hear, but Dennis was asking, what if we do that analysis of relating EC to yield, but we have reasons to believe that the EC here is maybe not completely driven by texture, but perhaps is being driven by other factors that we don't have a good proxy for. That could be the case, right? And two things that I would tell you about that is, one, the first step that we can take to avoid that is to take soil EC data under the conditions that we talked about in class and was also part of the exam, as far as like what questions would you ask a producer to make sure that your data is good and you can relate that to texture, because that's our goal, right? I mean, of course, if a producer has a saline or sodic soil, you know that is the main controlling variable. There's nothing you can do to make that different. There's nothing you can do to make EC be controlled by texture if the soil is already saline. It's going to be controlled by salinity. That's a fact, right? However, for other soils, for most other soils that don't have that specific strong underlying cause, which is salinity, you can then relate EC with texture. If you know the field have been, treated the same, if you know that it's been irrigated the same, there's no differences as far as that. Now, the other way to also address that after the fact is, let's say, if I have reason to believe that my EC data is not of good quality because it was a field that parts were irrigated, other parts were not, then you have reasons to believe that maybe another driver is driving yield, and you would like to understand the effect of that. The thing is, you have to have that layer, whatever you think it is, right? So if you think that this field has an elevation drop that is so high that is affecting yield, you have to have an elevation layer to check that, right? Or other, like if you think it's a nutrient, you have to have gridded soil samples to interpolate and then test that hypothesis. So you have to have that secondary layer to try to explain what your hypothesis is to begin with.
So you cannot make conclusion directly based on this.
No. It's a good layer, but we need other pieces of the puzzle as well to understand. Yes, Amanda.
Can we make NAs into the assigning a white color?
You mean like going back to the map
Just,
aesthetics
to
part?
assign that NA will be equal to all white color.
I think so. So Amanda is asking if we can change the color of the NA cells to white. I think we actually, let me just go back to the, I think we actually did that somewhere.
Color when plot background.
No, it's not here. So let me go back to the plot.
You put the gray color there, still, we can change that gray to white.
I think there's an option within the scale fill that is like NA, perhaps NA value. Yeah. Yeah, I'm gonna go back to what I had before, but this is, yeah, I mean, if you do want to change that part of it, that's how you would change, is what color is being assigned to NA values. Yeah. All right, okay, so this was great. I mean, sometimes I think I code too fast and I don't leave a lot of room for discussions or maybe even probing you on different questions. I want to start doing that more because I think that's going to help your learning. So this was great. Even though we spent a lot of time, it was really worth it. Okay, so the next thing that we want to do here is do the interpolation of the deep layer. So come to the next chunk. We're going to do that next here. So in your head, I hope you're already thinking that we need a function gstat. That's the first step of this interpolation method that again is IDW inverse distance weighted. The first argument it has is formula. So here we basically just say what is the column that we want to interpolate. That in our data set is called ECA 90 underscore DSM. And you have to say tilde1. We already talked about this, why we do that and not simply just say the variable name. And then we have to tell it the data where this column is. So that is an argument called data, and the data set name is ECA underscore W. So you can go ahead and run that, and you can print it just to make sure. Again, this is the first step of this interpolation method, which is basically just setting up the formula and giving the data set object where this data is coming from. And then the second step here is, if you come on the next chunk, is to actually predict this formula and this data based on our grid. So to do that, we use the function predict. We give it the first argument is this formula that we just created above. So that's the ECA 90 IDW mod. The second argument is the grid that we want to use to interpolate over. So that is an object that we created previously called grid underscore R. Go ahead and run that. And if you want to print it, you're going to notice again that this is a stars object, and it has again the same two columns, var1 pred and var1 var. And the next step here is the plotting. I left you the code, because it's basically the same code as we developed for the shallow layer, the 0 to 30 centimeter layer. The only few differences here is that the data set coming in is obviously different, right? Is the one that we just created above for the deep layer. And also I just changed the name on the legend to now say 0 to 90 centimeters. Before it was 0 to 30. So if you just run it and you print it, this is what it looks like. And lastly, I just want to plot them together side by side so you can see it. And again, I just want to tell this again for us to remember. So whenever you give two ggplot objects and you separate them with a plus, this plus here is coming from package patchwork, which is a package that allows us to combine multiple plots. If I had not loaded package patchwork in the beginning, as we did in setup, but if we had not, this plus here would have been coming from ggplot2 package, and it would have given you an error because this plus for coming from ggplot only works within one ggplot call like we're using here, and not to combine two ggplot objects. Just wanted to make that differentiation. So here is the output of both of those. So electric conductivity at the shallow 0 to 30 centimeter layer and at the deep 0 to 90 centimeter layer. Now,
So is that a question?
yes, go ahead.
And this could just be a misunderstanding here in Tifton, but I thought that the way that the Soil EC come out was shallow was from 0 to 30, and then deep was from 31 to 90.
Yeah, so I can double check on that and just get back to you. But my understanding of what it is and how it works is that it actually, like, because the way that the technology works, if you recall from the slides, is you have disks that emit the electric current, and there are other disks that receive it, right? So the disks that are closer, so the receiving disks that are closer to the emitting disks do the shallow, because the electrical signal goes through like a shorter path, and the receiving disks that are farther away from the emitting disks are the deep ones, because the signal goes a deeper path until it gets to it. So just thinking of the way the technology works, I don't think that there is a way that you can cut out and say 0, 30, 30 to 90, right? Because the signal is going throughout the complete soil profile. So I think it would be like integrating over the entire profile just to a deeper depth and not saying this and this. Does that make sense?
Could we calculate, once we have our deep soil EC, like could we calculate using the 0 to 30 to calculate, maybe taking out the 0 to 30 so that we could do 30 to 90? Like with the data we have, once we ran that.
So yeah, I mean, mathematically speaking, you can, right? And it makes sense. I don't think I've ever seen that done, and maybe it has been done, but I haven't really read any papers that did that. But I mean, we're not going to be doing that. But if you want to do that for your research, maybe need to look into the literature and see if that has been done and defended in a way that is accepted. Yeah, I guess that's what I would say.
That last part.
Yeah, but that's a great question, because if you're taking a soil sample, right, you have the physical sample that the depth and you can cut whatever threshold you establish. Here is not like that, right? It's just that the signal is going through a deeper portion of the profile and integrating over it. So I think it would be like 0 to 90 instead of 31 to 90. But we can certainly check that, but that's my gut feeling and based on how it works, but we can definitely check on that. Thanks, guys. Okay, so let me ask here someone else. Let me see online. Maybe Sarah. So looking at these two maps together, and especially looking at the scale of the color scale between them. Well, I guess like before looking into the color scale, just looking at the distribution of the data spatially on the shallow and on the deep one, what can you tell me about it?
I think it's somehow more homogeneous, the data for the second one.
Okay.
It seems like looking at the legend, less variability, something like that.
Yeah, I think I agree that the second one seems to be less variable. What can you tell me? Look, so now if you look at the color scales there of the legend, and you had to say the shallow layer is either coarser or finer than the deeper layer. What would you say about that?
Apparently the colors are sharper, so maybe it's coarser,
Which one?
the first one.
Okay. So let me ask someone else. Let me see. Tyner, what do you think? Which one of these layers do you think is like, if you look at the color of the legend here, would you say that the shallow has finer or coarser texture than the deeper one? You think the shallow is coarser than the deeper? Is that what you're saying? Okay. Anyone else thinks differently?
I think the shallow one has like more categorical, scale, so that it has more like, I mean, the second one has coarser and the first, shallow one has like smaller
Particles, yeah. Yeah, so I mean, of course, like we're not looking at the entire data here. We're just basing our conclusions off of the breaks that we see on the legend. So it's very subjective, right? But I guess just looking at it, my interpretation is, well, I guess before I tell you my full interpretation, let me give you a step before that. So if I look at the shallow one, 0 to 30, I see that values are ranging approximately from 2 to 8, at least on that legend that we see, right? And the values on the deep one are ranging from around 5 to 10. So to me, it's, and again, subjectively, I would assume that the deep one has higher values here, right? So if we have higher values, then what does that mean when we relate to texture?
That's why I said shallow would be cool.
Yeah. Yeah, so Tyner, you think that on the shallow one we have more sand or more clay?
Or I would say more sand.
Yeah.
So that's why it would be more force for the shallow.
Yeah. Exactly. No, that's exactly what I was going as well. So I think both Sarah and Tyner were thinking on the same way. I was just I guess trying to get more exactly to like looking at the values and doing that interpretation, but you guys were definitely on the right track. So yeah, so I would also assume just from looking at this that like our shallow is coarser, right? Because we have a lower range of values, and our deep one is finer, so it has more clay because we have the range of values extend higher, right? Which relates to finer texture. All right.
Yeah, we are showing
Dr. Bastos.
the soil conductivity has been
Just a sec, Shikhar. Yes.
measured by soil test.
Yeah, so yeah, that's a great point. So Peter is asking here, for us to make that conclusion, we are assuming that this data, this ECA data is controlled mostly by texture. So that is an assumption we're making. Yeah. Yes, Ticker.
Can we, make the legend, scale same for the two maps so that we can have, same level of color so that we can differentiate the, the color based on the color, between two maps?
Yes, we can. Yeah, let me see here. So I think that's actually a great exercise for anyone that's interested to do. I will do this, I will show you this next class, but it will, the steps, if you think of it, the steps that we would have to take is basically gonna be within the scale fill varieties. So the scale fill, we can provide it, let me see, I think it has a limits. It should have a limits argument, even though it's not popping up. So let me just try here. If we do limits, let's say 0 and 20, let's see if that works. Yeah, so it has a limits argument. So what we would have to do is basically change these two values 0, 20 to be the same for both layers. And if we want to do that in a more informed way, the best way would be to do a summary on both layers and see whichever one has the minimum value and use that minimum as here, and whichever one has the highest value and use that highest here, and then apply this part of the code equally to both plots. So we can definitely do that.
Yeah, thanks.
Yeah. Okay, so if you did not export, you can go ahead and export this plot. So we save it to file. And the next thing that we're going to be doing here is do the grid extraction. I think that we may actually, it's already 9:57. We end at 10. So I think we can stop here. And even though we didn't move a lot in the code, but I think we had some great discussions, conversations, and questions. Everyone was, helping out with us to think as a group. I appreciate that. And I think this is probably a good thing for your learning as well. As you can see, some of the questions that I ask you in class are some of the things I want you to be thinking, and some of the things I ask in exams as well. So I want to engage you more in class to get you thinking in the way that you'll be evaluated as well. So we can stop here. I'm going to create a GitHub attendance issue.
Can I ask a quick question, Dr. Bastos?
Yes, go ahead.
I know that you said that we will discuss this on Wednesday, but you got me a little nervous now. Well, could you tell us like the class average approximately?
Let me first create this issue here, and then we can talk about that.
Okay.
Okay, so I just created the issue. Go ahead and claim your attendance if you're watching live. So I have to go back and check, but I think the average was around 80.
Okay, well, that's not as bad as I was anticipating. You got me a little nervous on that, so I was like, oh crap.
Yeah, no, yeah, it was. Yeah, we'll talk more about it on Wednesday for sure, but I don't want to spoil it too much, but yeah. All right, any questions about today? If you do have questions about the exam, we can defer that to Wednesday during class or even after class if you wish. Yeah, and if you have questions about anything else, feel free to reach out to me. I'm finishing to grade your midterm, sorry, not a midterm, your mini projects today. So I'll be posting those grades today. So if you're anxious for that, that's coming out. And yeah, you'll get some feedback back as well to know, if you missed something, what was it and why you lost points on something. And again, if you have questions about that, feel free to reach out to me. We can chat about it. All right, I think that's all for today. Thanks, everyone. See you on Monday.